Hello and welcome to Geekatplay Studio Tutorials. In these tutorials we continue to look on Filter Forge and mostly we'll continue working with Filter Editor. So let's look right now on more options. We have it on components, and right now one we're going to look it is patterns. So right here we'll look on it first. It's called Bomber. So let's open it and look. The bomber is component that sprays particles in controlled manner. So you can see the different type of the particles. We also can see all these different options that maybe on first case look overwhelmed, that help us control the position of the particles. But actually when we look, it's the very self-explanatory and very easy to control. As well, we have the controls options here. Okay, so let's look closer. The one you'll notice right here, we have a particle, and we have a particle 1, 2, 3, 4, and 5. It's an input. And this is a map input. Those input are specified particles that sprayed on our image. So as example, we'll go to the gradients. We'll take one. And you notice if we connect to the particles, now this particle is using that map input from our gradients. So as well, you can use it just different image or any other input that can apply it as well. You can also using HDRI image, but for this, you actually need to go ahead and using Bomber HDRI type. So it's two different. And when you're creating, and if you want to work with HDRI, be sure you're using this one. Otherwise, they're all very similar. So we'll just look on one, and it will apply same settings will apply to HDRI, only with exception this will using high dynamic range image as input. So right here we have a particle 1, particle 5 that they can have accept input and any mapped kind of input. Next we also have chance and a chance 1 till 5 which apply to particles, and those inputs they actually define chance of specific particle to appear on output image. So let's look right here right now. For the first one we have it 100%, so it will be 100% the particle will appear, and you can notice we can specify all the way to the 0, and when it's 0 none of those will be appearing. So in this case, we can specify what is the chance of this appear. In other cases, it will create random number from 0 to 100% of appearing of the image. So because if we're going 100%, we will be sure at least once this is parent or this is particle will appear on our image. Again, it doesn't tell how many times, it just give it a chance. So 100% for sure at least one will be, or if 0, it's a none will be appear. Okay, so and we of course we have the chance from for all different 5 particles which applied. Okay, next we have a background color, and background it is a map input, and it's obviously define the image that appear as a background. And currently you can see we're using gradient colors, and they appear on the background. And in ways you can just take a normal image and you can apply a different effect maybe over with the options of the different colors and chances they appearing over them. Okay, next we also have an opacity. So the opacity, you can see it will affecting of the particles with what opacity they will overlay over background colors. This is a kind of will affect all 5 different particles. So in some cases, it's a more kind of global effect on all particles for this. Okay, next we have its size. Size, same like opacity, affecting all particles at the same time, and it will control the size of the particles that appear on our image. We also have an option rotation, same as before. This is applied to all 5 particles, And will set angles from 0 to 360 degrees rotation of the particles in our scenery. We also have offsets for the horizontal and a vertical, and this is also accept as the you notice right here green. All green is a map input, so it's accepted map input, and with this we can actually offset them on horizontal or vertically. And this is actually kind of useful when you want some repetition or you want to effect by maybe going on the edge of some other image. We also have the squash, and it specifies how particles are squashed. So you can see on what direction. Okay, and because currently we have it our rotation, so let's go ahead and set to 0-degree example. Okay, you can see it's going horizontally or vertically. Squash on our particles. The one interesting things there, because the squash is a map input, it's allowed you to control the amount of squashing for the individual particles separately with map component. And of course, when it's connecting directly to the our scenery. So we'll go to the noise, or maybe actual gradient, and we'll get elevation map. Okay, let's go just select some noise. Okay, we'll connect this to elevation, connect to the gradient, and we'll connect to the squash. So you can see they're all squashing separately based on our input. So, or we can go just directly right here. Okay, and you can see because it's a map controlled. Now all this they're squished separately based on the map control. So this is kind of beauty of the using this map controller. So you can control individual particles, how they will be affected. Okay, next we have it opacity chaos, and this is a map input, and this is defined the amount of randomization that apply to opacity for each particle. So if before we have it kind of like global, so on this we can apply to an individual as well. Can be controlled through the map, so you can open and create the opacity for each particles individually based on a map input. Okay, as well we save it size chaos, that is as well can be applied a size for individual particles, so we don't need it use the global size kind of resizing. Okay, we can just go ahead, connect and use map input to control individual particle size based on a map input. Currently we're using the one noise. You can use a different noise for different. So you can see we can control all of that, creating more interesting randomizations in our particles. We also have it up for the chaos vertical and horizontal. That is define the amount of randomizations that applied on a shift for the horizontal or vertical. And again, if you going all the way to the 100, that is no randomization, kind of will apply maximum randomization. And again, if we're going to the 0, it's a no randomization will be applied for the horizontal or again vertically. So again, if we're going all the way, you can see it's much more randomization applied at this point, and if we're going all the way to the 0, it's much less. Okay, we also have it options next. It's a squash chaos, and it's a very similar options that it can be controlled by map input on the individual particles. So in some cases, if you look right here, we have these options right here before, which apply globally to our particles, and we have a map input right here below that is can be applied to individuals. So we can go ahead and, for example, have it on squash, and you can see it's applied to different particle individual based on a map input we put it. Okay, next we also have it a tint control, and this is overall applied to overlay. So let's go ahead and, as example, if we change, you can see right here the tint start applying to ours, and this is our tint control. It's actually specify the overall tint on our particles. We also have the options, the tint amount that can be applied to our particles. Okay, and in some, if you work with imaging or like with effects, you can take average color of your photo and apply over the particles. On this case, your particles average color or tint will match the image you're processing. So it's kind of nice way you can blend the particle with the image that you try to import. So let me show you as example for this. So let me close it. Okay, I don't want to save this one, and we'll just go ahead open. Okay, so example right here, I have an image of the spider. Okay, we'll go to right here. We'll take again now. I don't really have it bomber right here. We'll go ahead, have it external. We'll take our image, and we'll take our average color. Okay, we'll take our image and set maybe as a background, so you can see right here. And we have it our average color, and when you can take this average color and set up to the tint color. So we link, and now if you notice, we can apply overall tint amount, and now our particles, they will kind of work together with the image, so they're matching this average color on our image. In this case, they don't look too off. So again, if we remove it, you can see that obviously they do not kind of matching our image. So, and this is in a nice way when you start working with a particle and you're creating, you can kind of try to match with the image colors. Okay, so next we also have it roughness. The roughness is just the roughness of the particle patterns. So let's get right here, just increase and see. Technically, a roughness is defined the relative transparency of the particle layers and the detail of the parameter. So in some effect, it's best if you kind of preview and see how they will affect. So we have a decreasing roughness, and right now we kind of start increasing. You can see we have a small teeny tiny particle start, and in a big picture we increase this roughness over our image. Okay, and again with combinations with increasing chaos and maybe increasing some chaos rotation as well as opacity, we can add this green chill look to our image. And again, the roughness will help us if we add a little bit more towards that. Okay, so this is our mapped input kind of overview. Next, we have the control input. Okay, at first we have it, of course, the particle mode, and this is a blend mode. Again, in some cases, you will be very familiar. We have a normal, overlay, or color burn, depend how particles you want overlay. And this, as you can see, this have a very interesting effect already just to apply overlay for type of particle mode. Okay, by default you have it normal. If you want a little bit lighter, you can go with a soft light or some other one, but in some cases this give you this greenish as well work. Next we have it also the tint mode, and this specify the amount of the tinting that apply to the particles. And again, this is very similar, so we can go ahead and set overlay, for example, and You can see how that will affect it, but or saturation, so we can remove some saturation in those particles. We also have an effect of the layering, and the layering is specify the way the details and roughness inputs affect the relative transparency on particle layers. So let's say simple normalize. Okay, we can preview right here. Okay, we can go ahead, select balance it, or just simple. Okay, you can see in a way it's affecting. And of course, the normal is just what you have a default. The balanced mode, it will calculate actually layer transparency, and using this algorithm in a fractal noise, like Perlin noise as example. Okay, and when we have it both simple and simple normalized node, that will arrange the relative transparency of the particle layers in a linear progression. I know in some cases it's kind of a lot of words. The best way, just go ahead and try to use it and see which will affect applied closer to what you like it. Okay. Next we also have it options. It's details, and details will adjust the particle parent complexity. The problem with this, it will give you greater result when you're going higher, but it will increase render time. So if you're going for the quality, you can increase, but if you're going for the time of render, you want to decrease. So it's good balance between all of them. The repeat is specify the number of the cells in a layer with the largest grained particle grid. So as example, you can see we can increase amount, and it is affecting. So it's a subsequent grid that will have about 4 times less cells than first ones, and so on. So it's increasing. And again, in many cases, if you keep it probably around between 10 and 20, that will give you excellent result. But in some cases, maybe for higher noisy, you want to increase higher. We have a density that will specify number of the particle per grid cell. Again, remember, we have a different type of particle grid, so and it will specify per each of them. So it's a little bit more global applied to all of them. Okay, and you can see with higher density, we kind of start losing all the details. So if you, as a basic about one, but on some maybe background creation, you maybe want to go a little bit higher. Of course, in a variation, it is just change your random seed on your particles. So in some cases, maybe you want different type of variation for the particle seed, so it will help us. Okay, and this is our kind of bomber that we using one of the pattern. Bomber HDRI, how I said before, it's very similar to the what we look right now, only it will accept HDRI input and it will produce HDRI on output. So let's go ahead next and we'll look on the bricks. Okay, right here. Brick is very basic and one of the first component that created. This help us create a brick look layout in a pattern. We have it mapped input, and we'll have it color for the brick, color for the model. Of course, those is how can be accepted. Okay, let me go ahead, select different one. Mapped input, so it can be your image or it can be just grid, and you can notice right here we applied to different type model or a brick color. Okay, we also have it hue range and low range, so we can kind of apply a range for the colors readjustment. Again, because they are kind of dramatic change, in many cases you want to keep it on lowercase, except maybe you're going for the some clown type of the bricks, or but in many cases you want maybe keep it in lower values. Okay, And again, this is representing as a HLS type of the color control. Okay, we also have a mortar width where we can increase or decrease mortar between the bricks. And we have it also the bevel, which is add this little bit kind of fuzziness or a Gauss blurring on the edges of the bricks. As well, we have at corners that we can add kind of smoothness around the corners, and you can see right here. Bond is kind of very interesting control input, and this is let us how these bricks will position of each other. So you can see this normal running. This is 1/3, so we kind of start having on 1/3 moving, 2/3. Okay, we also have it parking left, so it's everything going right there. We also have it stuck, when you can see how they kind of stuck on each other with, and different type American way. You can see we have a smaller brick between bigger, so it's different type how the bricks can be laid out. Okay, also we have a different brick of type. You can swing with a jumbo style, longer standard, so it will give you different type of applying. And of course we have it different filling type of the mode between a solid fill or this, and for that let me increase just slightly stuff, so you can apply it and preview different type of the fill mode. We also have it repeat, and in some cases think about this as a scale for ours. It does not apply to the overall scale, global scale, but it is applied to specifically our component. Okay, the chaos, you can notice it will add random. Again, 0 it's no chaos, and 100 is a maximum. It will apply to the mortar width, depend, and also positioning of the bricks. Okay, variation will help apply the different random seed when it's creating for the bricks. We have also the, in a way, the bevel. Okay, if we look closer, how the bevel width will applied and to this blurring effect between mortar and a brick. So we can specify if we want smoother going around its or linear. And you notice this is a blue color, so it says it will accept curves input. So in some cases, if you want to create like step curve applied to this, you can see right here, if we look closer, our bevel is have kind of step in a way it's applied. So let me go ahead and increase. And right here you can see we have kind of steps going from our curve as we applied. Okay, so right here, this is again, that was our brick. So let's go ahead and check checker now.